Hey Cyclones, this is Mr. Pickett, and specifically I'm looking at you, my Unified Science class. I hope you're safe and you're doing well, and I hope that you have maybe a little bit of time to learn a little bit about science while we're on break here. So what we're going to be covering in the next couple weeks is humanity's impact on climate. And before we dig into that, we have to definitely talk about energy. And the reason why we need to talk about energy is because energy is one of the reasons that we have climate. And climate is kind of a bigger version of weather and a more sustained version of weather. So the reason why it's raining outside, the reason why there's snow on the ground, the reason why it's really, really dry sometimes has a lot to do with how energy moves in our Earth. And so where does energy come from in our Earth? Well, there's two main sources that our Earth actually kind of gets energy. One, of course, is our sun. It probably gives us over 99% of the energy that we have. But the other that does play a role in our Earth as well is the interior or the inside of Earth. Now, once the energy gets here, there are three different ways that this energy actually goes from point A to point B. Or even as it gets from the sun to Earth, there's a way that this energy actually has to move or propagate. So the easiest one to recognize is conduction. So if you've ever put your hand on a hot object before, like a toaster, for example, I actually burned my finger on that when I was a kid. There's a conduction of energy between normally solid objects. So solid pieces of matter that touch have the ability to exchange energy. Another one that is kind of difficult sometimes to conceptualize is energy moving from point A to point B due to radiation. Now, radiation, and you can actually see it in this picture here, the reason you're able to see the red hot pipe is because some energy is actually leaving the pipe in the form of electromagnetic radiation or radiant energy. And this is radiant heat. So if you've ever been next to a fire before, you can actually feel some of that radiant energy being given off. The last way that we transfer energy is through a process called convection. And convection is most similar to conduction. So conduction is when we have two objects, normally solids, that are next to each other that basically transfer energy from one object to the next. Convection, on the other hand, is when two objects or pieces of matter are kind of close to each other, or even it's one big piece of matter, and that matter is actually not solid. It's more of a fluid. So it can be an example of like a liquid or a gas. Because of the flowing nature of fluids or liquids or gases, the matter has the ability to move a little bit easier. And so if something has a lot of energy, it has the ability to slip past stuff. So convection is when, like in this picture, is when this energy is actually touching the air, and the air is actually becoming energized and it's moving as a result. Okay, so let's give an example of this convection occurring underground, specifically energy that exists inside of our core or maybe throughout the interior of our Earth. So generally, it's believed that the warmest part of our Earth is the core, the very center. And where is this energy, like where did it come from? Well, there's two thought processes. One of them is from the Earth's formation, basically small little planetesimals or just little rocks were slamming into each other over and over again at high rates of speed, and it created a tremendous amount of heat. And as the Earth continued to bombard itself with more of itself, where'd that energy go? Well, it got locked away inside and it slowly released over the millennia. The other way that we basically get energy emitted from the inside of our Earth is from radioactive decay. So these are atoms that are kind of unstable, and they're pretty rare, and they basically break down because they're unstable, and they break apart into two smaller atoms that are more stable. But during that breakdown, they release energy. So we get energy that's released from the interior of our Earth, and that energy's got to go somewhere. That's what energy does. And so what happens is that energy is going to come in contact with matter, stuff, atoms. And what it's going to do is it's going to cause those atoms to behave a specific way. And what happens when warm matter basically heats up. It becomes less dense. It spreads out, and as a result of becoming less dense, it will actually move away from the middle of our Earth. As that matter moves further away from our heating element, or the very center of our Earth, it's going to start to lose some of that energy. If you ever move away from the fire, you become colder. So as matter cools down, it becomes more dense and it sinks back towards the center of our Earth. So this is how matter or energy actually moves its way from the interior of our Earth to the exterior of our Earth. Now, there are also a couple other things that are kind of important. So our sun releases energy in the form of electromagnetic radiation or radiant energy, and that sun energy, that light, is actually, it's more than light. There's a lot of other things, but the light is actually going to move and hit our Earth, but it's not going to hit the Earth with equal intensities. So because the Earth is spherically shaped, the equator is actually going to receive more intense radiation than the edges or the poles of our Earth. For the most part, the Earth is tilted, and there's a lot of other things that are associated with this, but there's some imbalance of energy from our sun just due to the shape of our planet. Now, because of this imbalance of energy, there are parts of our Earth that receive a lot of energy or a high amount of energy, and there are parts of our Earth that receive a low amount of energy. High amount of energy is probably going to be our equator, and low amount of energy is going to be our poles. So if our equator receives a tremendous amount of energy, that matter usually is really warm, so that water or that air is really warm around the equator, and as a result, it rises, right? It becomes less dense. And it will start to move potentially away from that area. And it will move to places where there is not as much energy. That's kind of what energy does naturally. And what we'll notice is we have these air currents, and we have prevailing winds, and we have ocean currents as well. And they all exist mainly due to our imbalance of the previous slide, the imbalance of energy actually striking our Earth. There's other things at play too, like the rotation of our Earth. The moon has an effect on some of these things as well. But these convection currents are a direct result of these heating imbalances. Now, the last slide that I have here for you today is mainly a rehash of the greenhouse gases. And the only reason I show this is because we need to recognize that this occurs. It's a naturally occurring phenomena, and if we want to understand how humans have potentially impacted our climate, we need to understand how our climate operates. So you can read through that. All right, Cyclones, I hope you stay safe and have a great week.